Hello everyone, welcome to my YouTube channel, and in this video I'll be taking you through a problem that we can solve using artificial intelligence. So our problem is entrepreneurs using e-commerce face a problem of lack of customers since most don't know about their sites and don't know what they are selling. The same problem arises to customers when they look for items they want to buy but fail to get the right source to buy them from. So you're understanding what I'm trying to say is that people who deal in e-commerce are looking for customers but don't have where to find them, and the people who want to buy certain items don't know the right sources where to get them from. So that is our problem, and our solution is going to be, so the solution, how about a customer recommendation system which uses Google search history to recommend some items they search for the most. This creates market for the goods on the market and helps to satisfy the demand of the customers. In my next slides, I'm going to be taking you through the types of data to solve the selected AI problem. And our first type is the numerical data. Numerical data, or you can call it quantitative data, is any form of measurable data. For example, one in digits like 1, 2, 3, and more. Then another category is the categorical data. Categorical data is defining characteristics. For example, the gender, that is the sex, hometown of someone, and so many others. Then another type of data is the text data. By text data, I think you're understanding what I'm saying. These are words or phrases that we use in solving our problem. So in the next slide, you're going to see the differences between supervised and unsupervised learning as used in artificial intelligence and machine learning. With the supervised learning, it is a type of machine learning method in which we provide sample labeled data to the machine learning system in order to train it, and on that basis, it predicts the output. So in the supervised way, we get labeled data and feed it or give it to the machine such that it adopts and it trains what it is going to be doing. Then with unsupervised learning, this type of machine learning technique in which models are not supervised using training datasets. Instead, models themselves find the hidden patterns and insights from the given data. Here we don't train them using labeled data. They find the patterns themselves by going through that data. Then in my next slides, I'm going to be showing you supervised learning techniques. Under supervised learning techniques, I'm having two of them. The first one is regression algorithm. Then the other is classification algorithm. Regression algorithms are used if there is a relationship between the input variables and the output variables. It is the prediction of continuous variables such as weather forecasting, market trends. Then under the classification algorithms, we have the output variables in categorical, which means that there are two cases such as yes or no, male or female, true or false. Let's go to our next slide. And in the next slide, we are having the unsupervised learning techniques. Under the unsupervised learning techniques, we also have two categories. The first one is clustering, and the second one is association. Clustering is a method of grouping the objects into clusters such that objects with most similarities remain in the same groups, whereas those with less or no similarities are put in other groups. Then association is a type of unsupervised learning method which is used for finding the relationship between variables in large databases. So we are going to be moving on to our next slide, and these are the artificial intelligence technical challenges. And the first one, we're having the bias problem. So when we look at our problem, we find that some people are biased when it comes to internet. They'll find recommendations, but they'll be like, no, those things don't exist. Those things are for frauds. So they won't be taking it seriously. Then another one is data scarcity. Data scarcity comes in whereby people don't use the internet, people don't search of what they're interested in. And remember that our artificial intelligence system is going to base on the previous searches or the history. Then another one is the wrong data that people feed into the internet. Someone may be interested in something else, but then they check for another thing. Or someone may use some other person's phone to check for what they want. So they will recommend that to a person who doesn't need it. Then another one is a limited number of people who use internet, and this is most common in rural areas where we find that there are very less people who use the internet. Then we are going to talk about the possible solutions to the problems that we've mentioned above. So the first one, we're going to be sensitizing people about the importance of the internet. We're going to be telling them the advantages of using the internet, because when they use it, they'll get recommendations such that they get what they want. Then we're going to extend this artificial intelligence system to social media platforms, because someone may not use Google, but that person may use Facebook, that person may use Twitter, that person may use Instagram. So we are going to be extending them to social media platforms. Then the last solution, we are going to compare different searches such that we get correct data. We won't be basing on one search that a person does. We'll be looking for different searches. For example, when someone searches today, you get that information even the following day, even the day after. When you compile it, you come with something and search, like you recommend something that someone has searched for like at least 3 times, not once. Yes. Then we're going to go to our next slide, and those are going to be the differences between accuracy, recall, precision, and F1 score. Then with accuracy, it is the number of correctly predicted data points out of all the data points. So what are you trying to say? Out of all the data points that are there, how many were predicted true? That is going to be the accuracy. Then when we come to recall, recall is the ratio between the numbers of positive samples correctly classified as positives to the total number of positive samples. So we are going to see here the total number of positive samples we correctly classified to the ratio of positive samples. Then precision is one indicator of machine learning models performance, that shows the quality of positive prediction made by the model. So out of the positive predictions made by the model, what is the quality of our prediction? Is it 100%? Is it 90%? Is it 70%? So when we see under that category, it is what we call precision. Then we're having the F1 score, which is the performance metric for classification, and is calculated as the harmonic mean of precision and recall. Let's move on to our next slide. So we are going to see the artificial intelligence evaluation metrics for the project. The first one is going to be classification accuracy, and this is what we use. We usually mean when we talk of accuracy, or it is the ratio of the number of correct predictions to the total number of input samples. Then another one is called logarithmic loss, or you can call it the log loss. It works by penalizing the false classifications. And those have been our AI evaluation metrics. We'll go to the next one, and this is our relevant references. If you want to see where we got the information we've been talking about, you can go to these sites and get more information from there. Otherwise, that's all. Thank you for watching this video. Let me hope to see you in the next one. Have a nice time.